For billions of years, nature's had this incredible solar power system, totally perfected. So today, we're going to look at humanity's big, ambitious attempt to copy that masterpiece. We're talking about a technology that could literally change everything. Let's dive in.
So, what if I told you we could make fuel from just sunlight, water, and the air we breathe? I know it sounds like something straight out of science fiction, right? But it's not. It's the whole idea behind a field we call artificial photosynthesis. Okay, so before we can even think about building an artificial leaf, we've got to understand the original, right? The blueprint. Let's start with the process that powers, well, pretty much all life on this planet. Yeah, I know we all learned this back in biology class, but it's worth a quick look. At its heart, photosynthesis is just nature's genius way of bottling sunshine. Plants grab sunlight, water, and CO2, and they turn it into food for themselves, glucose. And the byproduct? Oh, just the oxygen that we all need to breathe. No big deal, right? It literally powers our entire world.
So just how important is this? Let's put a number on it. Plants are absolute workhorses for our climate. They soak up about 30% of all the CO2 that we humans pump into the atmosphere every single year. I mean, think about that. Nature is already doing a huge part of the cleanup job for us for free.
And you know what's crazy? This idea of copying nature isn't some new fad. Way back in 1912, this chemist, Giacomo Chiamiachian, had this incredible vision. He imagined a future where we wouldn't need to burn coal. Instead, we could just use chemistry to harness sunlight directly. This quote is, wow, it's so ahead of its time. He basically predicted the entire field.
So, that brings us right to the modern-day quest. How do we take that century-old vision and actually make it work? Let's take a look at how scientists are trying to build on nature's perfect design. All right, so this is the endgame. Instead of making glucose to feed a plant, artificial photosynthesis is all about creating real, storable fuels. We're talking about hydrogen or maybe methanol. It's like directly turning sunlight into a liquid you can put in a tank and use whenever, wherever. And the best part? It would actually consume CO2 in the process.
Okay, so how does this magic actually happen? Well, it really just copies nature's playbook, breaking it down into 4 main steps. First, you've got to harvest the light. Just capture those photons from the sun. Step 2, you use that energy to create what's called charge separation, basically knocking an electron loose and leaving a positively charged hole behind. Step 3, that hole is put to work, splitting water molecules. And finally, step 4, the electron you freed up gets used to turn CO2 into a useful fuel. It's a beautiful little assembly line. And this diagram really shows you that process in action, so look right there in the middle. See that HV? That's a photon of light, sunlight, hitting the system. It energizes an electron, which then zips over to the right side to help make fuel from CO2. Meanwhile, that hole it left behind, it's used to kickstart the reaction at the bottom, splitting water. See, it's this perfect closed loop, all powered by nothing but light. Now, when we say artificial leaf, you don't have to picture something green and veiny. It can take a ton of different forms. I mean, look at A. It could be as simple as tiny particles floating in water doing their thing. Or it could be a more complex device with electrodes like in B. Or even a full-on hybrid panel like you see in C. The shape doesn't matter as much as the job it's doing, nailing those 4 key steps.
All right, so we've got the original champion, nature, and the new contender, the lab. Let's put them head to head. How do they really compare?
Okay, so the biggest differences really boil down to 2 things: the tools they use and what they make. Nature's got chlorophyll and all these super complex enzymes. The lab, we're using man-made catalysts, usually built around metals. And the end product is totally different. Nature's just trying to make lunch for itself, glucose. We're trying to make high-octane fuel to power cars, planes, and cities. Okay, get ready for a shocker. For all its beauty and perfection, natural photosynthesis is actually not very efficient. At all. Most plants convert less than 1% of the sunlight that hits them into energy. And it makes sense when you think about it. A plant isn't trying to power a city, it's just trying to survive. It's got to grow, repair damage, and just, live.
Now hold on to your hats. In the lab, scientists have hit a record of 19.1% efficiency. Let that sink in. That is 20 times more efficient than a typical plant. And that right there is the whole ballgame. That's the massive advantage of building a system from the ground up designed for one thing and one thing only: maximum fuel production.
So, if it's so much better, why aren't we all fueling our cars with this stuff already? Yeah, good question. As you might guess, there are a few pretty big hurdles we still need to get over.
Yeah,
Going from a tiny device in a lab to something that can power a country is a massive leap. First off, cost. A lot of the best catalysts right now use super rare, super expensive metals like iridium. That's not going to work on a global scale. We need to find cheaper alternatives, using common stuff like iron. Then there's stability. These things have to sit out in the sun and rain for years, maybe decades, without falling apart. And finally, there's just the sheer scale of it all. Making millions of these things is a huge engineering challenge.
And to zoom in on that catalyst problem, splitting water, we've actually gotten pretty good at that part. It's like we've solved the first half of the puzzle. But the second half, turning CO2 into a complex fuel like methanol, that is way, way harder. It's the real bottleneck, and it's the big scientific puzzle that everyone is racing to solve.
But here's the thing. Even with all those challenges, the excitement in this field is just off the charts. The momentum is real, because the payoff, it's just too big to pass up. And you don't have to take my word for it. Just look at the data. This chart shows the number of scientific papers published on this topic, and it nearly tripled in just 5 years. This isn't some quirky side project anymore. This is a full-blown global scientific race.
And you know what follows the science? The money. Big time. We're seeing huge initiatives, like the U.S. Department of Energy throwing $100 million at this. When governments start putting that kind of cash on the table, you know they're taking the promise of solar fuels very, very seriously.
So we come full circle right back to the simple leaf. For billions of years, it's been quietly mastering the art of turning sunlight into life. And now, it's our turn. Our turn to learn its secrets, to build on its genius design, and maybe, just maybe, power our entire future with nothing more than a little bit of sunshine, water, and air. The question is, can we do it?